Still got the Hendey shaft to make. Ooh, let's do an update. See, there's the gearbox that needs the shaft. It's totally random. Doozer shop. Right? The mighty Pratt & Whitney. Let's see here. All right. Bada bing. Oh yeah. Look at that, right? And this thing, man. I cut it a little on the loose side because I know it's going to get heat treated and it might shrinky dink or expand. I'm not sure which. So that's cool. Yeah, it needs to eventually look like that, right? Woodruff key, a regular key. So that's coming along. Right? Love it. Okay, gotta love it, right? All right. So I got my fishtail gauge, of course. Right? And you want to thread up to the edge, a shoulder, right? So that's kind of what you do. Come on, focus, right? So that's the shape of bit that you grind, and you try to, you know, bang. You try to grind it, make it fit. That's that. Okay, sorry for the super duper camera work. But that's fun. That's coming along, all right? All right, let your dim light shine. All right, perfect. All right, back to the agenda to show you guys the Bridgeportimer. So this, let me show you this. This is the forward reverse for the single dog clutch on the Hendey. And my buddy Bob Brownie Sharp over there in New Jersey, he showed me on his, he put like the stop rod attachment. Like they didn't come with a stop rod. And it kind of has a hole in the top cover, but it's reverse acting. So you cannot hook it to this side, right? It's got to be reversed. So it has to, he sent me a picture. He made his and it somehow connects to here. And it snakes at, like, you see that, you know, shoot a shotgun through that opening? Somehow, there, that's how it acts. It's like a 5/16 rod. So if I duplicate the pop stop, I have to do that. But at least I know what it does because Bob sent me pictures. So cool. Thank you, Bob. Oh, one thing I fixed the light buzz. You guys need to watch Cold War Motors. The buzz is gone, right? The buzz is gone. I took that apart, and there's two little transformers in there, ballast transformers, and one was humming, and I just loaded up the laminations with super glue and it fixed it. It's freaking quiet. Love it. Love it. The light buzz is gone. Yeah, watch Cold War Motors. This guy's working on cars, drinking beers. They're Canadian, so that's another reason I like them. I'm just still loving the beautiful fluid shape of my power feed handles here. I repeat things. Guys repeat things. Women don't understand that, but yes, guys repeat things because I don't know why, we just do. All right, Doozer shop. I just got done cutting the Woodruff key seat in the shaft for the Hendey tool and gauge maker lathe. That is a 404 cutter. It is a 1/2 inch diameter by 1/8 inch wide for a Woodruff key. And that's a D2 shaft. So I'm cutting it. It's 5/8 diameter and it's oversized. It's actually 0.642. The depth of the cut, machinery handbook says go 0.136 deep, but I'm going to go I just went 145. Actually I went like 146, 147, a couple thou deeper. Because of the bigger diameter, I'm going to grind off the final size on the grinder. So that's done. I went real slow, as you could see. I kept the rapid tap oil on it. Just went super smooth, super easy. I was worried about the air hardening aspect of the D2, but you know, I was going probably 200 RPMs, something like that. So that's very successful. You can see how I gripped it in the vise. I've got it on parallels and I'm squeezing it lengthwise through the nut on there just to give it additional flat, not to mushroom the end of the threads. That's the best way I could come up with on how to do this. I didn't want to squeeze it sideways, didn't want to put it in a V-block. I thought of a 5C collet block, but this seems to be the most rigid setup. And actually, for a little mill, this is pretty rigid because, you know, mills are like a letter C, right? The daylight opening, let me back up, right? The daylight opening is the letter C, and you know, if you look at a Bridgeport or whatever, the letter C is bigger. This is the Gorton right there. The letter C is bigger, so it's, even if you suck up the table, you still got the depth and the overhang of everything. So this little mill, for the little things I do, is quite rigid. It cut like butter. I didn't think to set up the camera. I probably should have. It took all of a minute to cut that, and I've been fretting about cutting it a little bit. I've been worried about how to do it and thinking about it. This seems to be the good setup. I touched off the top of the shaft, and I don't have a readout on the knee, but I just used the dial and cranked down half the diameter of the shaft plus half the diameter of the cutter, which is 1/16. So that worked out well. You can take into account the actual shaft diameter because the heat treat stuff is on there. The stock for grinding after heat treat is on there. All right, happy about that. And that went well. All right, guys, back on the Clausing 8520 mill. I was milling the keyway for the pulley, and I decided to make it 1/8 inch. I don't know if I should try to get the cutter. Yeah, got an 1/8 inch end mill in there. So if you look on the side, that's the Woodruff key I just showed last, key seat, Woodruff key seat, and here's the keyway for the pulley. And let me show you something real quick. So this is the old shaft. Of course, the Woodruff key seat there is 1/8 inch, and for the pulley here on the outside is 5/32. And why is it bigger? I don't know. You think you'd want the pulley key to shear before the gear key, which is inside between the casting features. So what I did is I made it 1/8 inch. And I'll tell you what I'm going to, because I want that to be equal strength or that's slightly weaker, but what I'm going to do is this. I was going to widen it out to 5/32, but I stopped. And the depth is proper for a 1/8 key, so it's 1/16 deep plus a little bit for the tolerance, like 2 thou for the tolerance of depth, and then plus 6 thou because 12 thou has to come off here. 6 thou radius. When I grind this, the depth of that will be like 265 from the surface, and that's about right for an 1/8 inch key, half the thickness. So I stopped, and I did not widen it out to 5/32. It's actually, I only had an 1/8 inch carbide end mill, so it's 0.126. I'm about 1 thou, maybe half a thou over, about 1 thou over, which is fine, because I'm going to make a custom key that's a T-shaped key. So the key will be 1/8 inch to fit in this keyway and 5/32 to fit in the pulley. And I could even make it out of brass if I so desired to make it a little weaker. I don't think I need to. I think just doing this is fine, because that Woodruff key seat there is also an 1/8, but it's deeper. Woodruff keys typically go deeper and are a bit stronger than square keys. This is an 1/8 inch square key, but it's a little bit longer. I think the strength is about equal. I know I'm splitting hairs here, but I'm kind of just trying to analyze the engineering. I wanted to make get a new Woodruff key and make a new square key for this anyways, because they're beat up a little, but that's what I'm going to do. And if I ever have to, if I ever want to change the pulley, I can broach it with a standard 1/8 inch keyway broach. 5/32 broaches are available from Shars and Doomore and Minuteman and all that, but 1/8 inch is more standard, and I don't think I need the strength here, and having it more equal is I think just better engineering. And a step key is super easy to make. I'll mill that up in 15-20 minutes. So the next step of this D2 shaft, I'll show you, I got the nut there for extra support, is to take it and harden it. Now I have access to a heat treat furnace. My friend Angel said just spin it in the lathe and hold the torch up against the bearing journals and harden it. You know, it's air hardening. D2 is air hardening, and just heat it up red with the torch and then blast it with the air hose, and then put it in the electric furnace for tempering once you air quench it. So we'll see. Just wanted to bring this to you. I really got the I got it on the, I don't know if you can see in there, a higher pulley setting. I don't know what RPM that is, but it's cruising. It's cruising. I'm probably 1,000 no, what am I? 2,000 RPM? Yeah. Like 2,100. I'm probably around 2,000-ish. Maybe 1,800. So for an 1/8 inch end mill, I like the carbide end mills regardless because they're just that much stiffer. So I had to go into the archive of end mills and find, I had a couple. I had about 3 or 4, and you know, they're in this section, and you know, I had 5/32 and I had 1/8 inch. You always want to use an undersized end mill to cut a key seat or a keyway, because they're going to wander and you're not going to get your size. Like I said, mine cut 126, and that's not a problem. It actually might shrink. That D2 might shrink when I heat treat it. So yes, to the end mill drawer I went. But anyhow, just kind of working on that this evening. hope you enjoyed what I just kind of gave you an update on the milling machine, what I'm doing with the shaft for the Hendey. Awesome. All right, I wanted to show you some progress on a project. Right here is the shaft that I made for the Hendey lathe, and there's the key seat with the woodruff key and 90 degrees off. I just happened to make it 90 degrees because it was in the mill, and I milled a keyway for the pulley, and of course the threaded end for the pulley retaining screw. I got this heat treated in a furnace, and my friend at work was running some A2, I think he was running some A2 in the furnace on a part he was making to repair a machine for production. So thank you to my friend at work, you know who you are, for throwing this in the mix. This is D2. It's also an air quenching steel, an air hardening piece of steel. And the recipe for D2 is to heat it slowly to 1500 degrees in increments of 400 degrees per hour. So, you know, 400, 800, 1200 degrees, up to 1500 degrees. And then after you slowly heat it up with this D2, you cook it at 1850 degrees Fahrenheit for, you know, there's formula, how thick is it, anywhere from, you know, I forget what it is, an hour per inch of thickness. This is 3/4 on that side. I cooked this for an hour, and I had it in the stainless steel wrap so it didn't oxidize. So in the annealed state, this is like 40-some C-scale Rockwell. This is supposed to get up to 60 Rockwell, 60 to 62 or 4. Well, this, we quenched it. Now it's air quench. Now we had it in the stainless wrap. We made a bag out of the stainless wrap, and we quenched it in oil, which is more aggressive, more likely to crack if you quench it in a more aggressive medium. You need to maintain the critical cooling curve, the degrees per reduction per minute, per second, whatever. But anyhow, this did not get as hard as I like. It's 56 C-scale. Now, I wanted to run needle bearings on this. Is 56 on the C-scale good enough for needle bearings? It's on the low end of good. I've seen 56 to 58. 60 is better. Like Thompson shaft is 60 case. So, I used the N scale and converted it. So it was like N88. Because I got like 16 thousandths of grind stock. So that's 16 thousandths. So that's like 8 thousandths per radius on each side. And if I would have done Rockwell C-scale, it would have punched through to the area where my finish grind wouldn't clean it up. So I think N scale was 88, which converts to 56 on the C-scale. So it could be harder than 56. I could check the butt end, but I didn't want to get into where I'm going to finish grind it. So finished, and because it was 56, I didn't run it in the 400 degree tempering. I hope that doesn't leave too much residual stress. I don't think it will, because it's not that 62 plus. It didn't come out of the oven 62 plus. I don't know if the temperature controller on the oven is exact. It's a big, beautiful electric heat treat oven, and the temperature controllers are these little itty bitty DIN 1/4 size. They're just terrible. I mean, it's a great oven. It's got a top main heat treat oven and a lower one for annealing or tempering. So I assume I didn't get this quite as hot. I left it in for longer than they recommended by a small amount for this thickness. So I think the time in the oven was right. I don't think it got to 1850, even though it said 1850. I don't know. Enough about that. But yeah, man, I don't know if we can tap on it. No, that's terrible. You probably can't hear it. Doesn't matter. It's hard when you go tink. Well, I can't do it, but I think it's going to be hard enough to work. So enough about that. Put that aside. Happy about that.